Alright, what is up, guys? Mr. C here with lesson 10.3, where we're going to be talking about areas of regular polygons. So really this isn't going to be any specific shape, but it's going to be like a 5-sided, 6-sided, 7-sided. No matter how many sides we have, how can we find the area of that? So let's go ahead and do this. So a couple things we need to know about polygons, and a new term we're going to learn coming shortly. Let's take a look at this picture here. All right, here we have an example of a regular polygon, and if you guys recall, regular means all the angles inside the shape are congruent, and all of the side lengths inside the shape are congruent. So it has equal side lengths, equal angle measures, and might look like a lot going on here, but let me explain. This black outline here, that's the shape we're looking at. So this is what? 1, 2, 3, 4, 5, 6 sides, okay? That's a hexagon, if we were talking 6 sides. Now, in order to find the area of a regular polygon, basically what you have to do is take the shape and you want to split it up into triangles. Notice these dotted blue lines split this hexagon into 6 congruent triangles. We have 1 triangle, here's 2, 3, 4, 5, and 6. Okay, so we have those 6 congruent triangles. If we find the area of one of those triangles, okay, multiply that by 6 because there's 6 of them. Basically, that's how we're going to find the area of a polygon. So if you want to think, we have this new term here. It's called the apothem. Okay, kind of sounds like you have a lisp when you say it, the apothem. A-P-O-T-H-E-M. Okay, that's this height of these triangles. So each one of these triangles will have that height of the apothem. Okay, so if we find this red dotted distance, it would be the same for each one of these triangles because all of the triangles are congruent. Okay, so that's how we're going to go about finding these. So before we actually find one of the areas of the hexagons or regular polygons, let's take a look at this. Okay, let's take a look at this. Okay. Now, what those numbers in there, 1, 2, 3, those represent angles. Okay, so we're going to find the measure of angle 1, measure of angle 2, and the measure of angle 3. Okay, so angle 1 is this angle here inside that triangle. Angle 2 is half that. Okay, it's right here, cut in half by the apothem, and then angle 3 down here. So we're going to do this a lot in this chapter. Okay, so try to pay attention. All right, this has 5 sides. Okay, so if we want to find one of these interior angles, okay, so this angle here, one of this angle here, which are all congruent, by the way. Okay, and I'll draw these. So like this here, this here, this here, that goes all the way, and then that one here. If we want to find those, think about how it's like they all kind of make a circle. We were to do those angles. And if you recall, a circle all the way around is 360 degrees. Okay, so if we have 1, 2, 3, 4, 5 angles that make up those 360 degrees, and they're all the same, we're going to do 360 divided by 5, and that's going to give us what these angles are in here, okay, which was the angle of measure 1 is what we're looking for. So if I take 360, okay, divide that by the number of sides, or the number of interior angles here, which is 5. What is that going to give me? That is going to give me a 72. Okay, so 360 divided by 5 is 72 degrees. Right? So that's this angle 1 here. All right, we've already found the first one. The measure of angle 1 is 72 degrees. Okay. So that means this angle here is 72, this angle here is 72, this one here, and this full angle from blue to blue is also 72. Now, what does that make the measure of angle 2? These apophthegms are actually angle bisectors to these interior angles. So if we're trying to find this measure of angle 2, which goes from that red dotted line to the blue, we're just doing 72. Divide that by 2. Okay, cut this full 72 degrees in half, which is, what is that, 36? Makes that 36 degrees. Okay, so the measure of angle 2 is 36 degrees. That's how we find that one. Okay, and then lastly, for this problem, find the measure of angle 3. Notice you have a right triangle here. These apophthegms make a right triangle. Okay, so we have this here. And if you recall, triangles add up to 90 degrees. So if this is 36 in here, let me zoom in a little bit more. This is 36 in here. This is 90. Okay, then what does the measure of angle 3 have to be? If we do, all these need to add up to 180, recall? Or we can just do, since it's a right triangle, if we do 90 minus the 36, that's going to give us the measure of angle 3. So 90 subtract the 36. What's that going to give me? A 54 degrees? 54 degrees. So that's the measure of angle 3 there. Okay. Measure of angle 3. Okay. So didn't do anything with area yet. Let me zoom back out so you can see the answers. Didn't do anything with area yet, but we are going to need to have this skill in order to find these angles. Because if you recall in the last chapter, when we were solving some of those triangles, we did require some trig, which some of these problems are going to require some trig to solve. So these are some pretty in-depth problems when we're finding area of regular polygons. They won't always be, but if they do require you to find some of these angles inside, then it probably will require some trig. Okay, so all right, let's try, or is that where I want to leave you? I think that's where I want to cut us off, just for the first day, Monday. Okay, so if you're the kind of person who wants to do half of it Monday, half the lesson, and then the rest of it Tuesday, this is where we're going to stop. Okay, and then give me 2 seconds to get this homework written down. I should have had this ahead of time. Here we go. All right. So, for Monday's homework assignment. This is Monday. Okay, just practice finding these angles in these 3 problems. So, homework, this is on page, and again, I'll have these pages posted at 632. Try numbers 8 through 10. Okay, so if you guys are just working on Monday and trying to keep on that kind of pace, pause the video now, get started on that homework, and then tomorrow you can continue to watch the rest of this video. All right, I will talk to you guys tomorrow. Okay, for those of you sticking around, let's go ahead and finish out our lesson for regular polygons. So, formula for regular polygons. Okay, we do have a formula. And going back, remember I explained kind of how we find the area is going to be by finding the area of one of these triangles. Okay, and multiplying that by the number of triangles you have, or the number of sides in the polygon. Okay? Another way you can think about that, a simplified version, and this is going to do the exact same thing as I just described, is if we have a regular polygon, I'll do my best to draw one. Oh, no, let me just take a picture. That'll go a little bit quicker. Okay, so here, and this goes for, it doesn't matter how many sides it has. Okay, there's a picture of a regular polygon. If we want to find the area, okay, we're going to take half of the product of A times P. Half the product of A times P. Now, what is A and what is P? A, again, is that apothem. Okay, A is the apothem, which is, watch if I drew that triangle, you can kind of see it. Okay, that's the apothem. And then P represents the perimeter of the shape. Okay, so how we're going to do that is find the apothem, find the perimeter, do half of their product. Okay, so let's go ahead and try one of those together. Let's find, well, let's start with a simple one. Okay, start with a simple one. This one we don't really have to do a whole lot of work because most of the stuff is already given to us. Let's look at this here. Okay, find the area. Okay, so nice thing about this one is this distance here, that already is the apothem. And this distance here, 8, that's going to help me find the perimeter. So before I can find perimeter, let's count how many sides I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decagon. So I have 10 sides. So if I'm trying to find the perimeter, 10 times 8, okay, that should be 80 inches for the perimeter. The apothem, again, was given to us. That is 12.3 inches. And then this is just a matter of plugging it into the formula and multiplying. So my area is 1/2 the apothem, 12.3, times 80, which is the perimeter. So let's go over to our calculator, multiply those out, and we'll get our answer. So we have 80 times 12.3, divide that by 2, and I have 492, should have been in inches squared. So 492 inches squared. And that's about as easy as those ones are going to get. We're going to try one that's going to require require us to remember some of the stuff from, what was it, Chapter 8 with the trig and all the right triangles. So let's go ahead and look at that one. Okay, and then we'll call it a day. Okay. So a lot going on here. Let's try to decipher everything. They gave us a side length, so that's good because that's required to find perimeter. And just before we move any further, remember, area is 1/2 apothem times perimeter. So we need P and we need A if we're going to solve this area. So if they give me a side length, that's 3. So how many sides do I have? I have 1, 2, 3, 4, 5, and 6. So we can find perimeter right off the bat and do 3 times 6. And that should give me an 18. Okay, 18 millimeters. All right, again, why is it 18? Side length is 3. We have 6 of them. That's going to give me my perimeter. What I don't have is the little a. I don't have the apothem, which is this distance. So we're going to have to think. If this is 1.5, okay, see this is a right triangle here. How can I find this side length given this side length here is 1.5? I'm going to, just so we can see it better, take this here. Oops, let me thin that up a bit. And take this here. Let me redraw that just so it's a little bit easier to see. There's a lot going on in that picture. So here's what we have. All right. We have this side is 1.5. We're looking for the apothem. We know this is 30 degrees. All right. So we did this a little bit in the last section. We have another 30, 60, 90, right? So we have this one opposite of 30 is the short one. So that's 1.5. If you remember, this here is twice that, okay? Which 1.5 times 2 is 3. And then if you recall how you get A is that short side length 1.5 times the square root of 3. Okay, times the square root of 3. Let's figure out what that is as a decimal. That way it's a little bit easier on us. So let's take LOS. Whoops, I just opened the same thing. Let's take 1.5 times square root 3. Gives me about 2.598. We'll round that to 2.6. Okay, it's about 2.6. And that's what we're going to use for the apothem. Okay. Now, if you are one of those students who just really struggles remembering those right triangles, those special right triangles, like the 30, 60, 90, the 45, 45, 90, you could have done something like, all right, if this is 30, that's opposite and adjacent. The tan of 30 equals opposite, which is 1.5, over adjacent. So if you remember how to solve those, you can go ahead and do it that way too. You'd still get 2.6 if you solved it that way. Which some of the problems, if they're not 30, 60, 90s or 45, 45, 90s, you're going to have to use SOHCAHTOA, either sine, cosine, or tan to solve that. But if it is a special right triangle, you can use this. At this point, does it matter which one you use? No. You'll get 2.6 either way. In the area, you'll get the same answer. So it's up to you guys. If anyone's struggling and needs a reminder on how to do these, let me know. I'll do my best to get back to you. But let's go ahead and proceed now that we have the apothem, which is 2.6. Area, again, 1/2 the apothem times perimeter. 1/2 of 2.6 times perimeter was 18. 2.6 times 18 divided by 2 gives me a 23.4. Right. So we have an area of 23.4. These were in millimeters. Millimeters squared. Okay, so that's my area. Again, what did we do? Find the perimeter. Okay, take the side length, multiply it by the number of sides, gives you perimeter, and then we'll have to use some kind of trig or special right triangle to find the apothem. Once you do that, use this formula, multiply them out, you get your area. So I hope that was clear, guys. Let's go ahead. So for Tuesday's homework, this is for Tuesday. Same page as Monday, which was 632. Okay. Let's go ahead. Let's try 22, which if I'm looking at 22, they give you the apothem. It's very similar to the last one we just did, except they gave you the apothem. Here, I'll scroll up. They gave you the apothem, and they want you to find the side length here to get the perimeter. Okay, so think about how you might do that. Is you set up this triangle the same way, except if you're given the apothem, how would you find this distance instead to get the perimeter? Okay, that's what you're going to have to do for number 20. What did I say, 21? I meant 22 if I said 21. And then try that one and also try 23. Okay, 23. All right, and since these are kind of longer problems, we'll leave it like that. Again, hope I was clear. Any questions, please either leave a comment on YouTube or Google Classroom, email. You guys have a million ways to get a hold of me. Let me know. All right, this is Mr. C signing out. Have a wonderful day. Don't forget to wash those hands. Peace.